Okay, so here is example number 2 of a type of problem where we're going to use the calculator to find the probability of a particular set of scores. But what we want to look at is something different, okay, where we're going to select a score that will be higher than 700. So instead of being between two values, we're going to go from one value to any extreme value we want. And so when we make a sketch of that, all right, I still have my mean in here, okay? I'm still going by standard deviations of adding 113 each time, okay? Um, and I'm still going to put in the value that I care about, the 700, but now I just care about anything greater than that, anything higher than 700. And so then I just start going this direction, right? Now this probability curve goes out forever, but it gets smaller and smaller and smaller. The area underneath this tail really goes to 0. And any of you with any calculus experience understand the limiting process that's going on here. But basically, the tail gets to be right on top of the x-axis, and the area underneath pretty much goes to 0. And this happens really far away. So I just want to pick a z-score that's sufficiently large for this. All right, and we're going to give you a rule of thumb that works out really well. Now, you calculate the z-score for the key values, but here we only have the one value, and we've calculated this several times before, so I'm not going to go into that. And we're still going to use the normal CDF command to get that area, all right? But here's where the difference pops up, okay? The shaded area has no right boundary, all right? So in the previous example, we had a left and a right, lower or upper z-score. This time we only have one z-score on the left or lower end, and then our shaded area extends to infinity. Well, we still need to give the calculator an upper bound score. However, the calculator does not have an infinity key. So instead, we have to use a very large number to stand in the place of infinity for our upper value. Recall that almost all of the normal distribution was in 3 standard deviations, so this means that a z-score of 3 is large. However, for good measure, you should choose something much larger, just to get an idea. One choice would be to use, and here it is, this is the key, 100, okay? While this is arbitrary, it is like using infinity since it is so much larger than a z-score you would normally see, and if we do this, then we get some good conclusions. Now, you are more than welcome to use 1,000. You can use 1e to the 6 for 1,000,000. You can do whatever you want in this circumstance, but what I found is these bigger numbers change the like 5th or 6th decimal place from 100. You're not seeing change in the first 3 decimal places that we're looking at when you use these bigger numbers. And 100 is nice, right? 100%, 100 points, we use 100 a lot. So this is a nice easy number to remember. So I go over to my handy dandy calculator, and again I'm hitting second, vars 2, okay? Now here my lower is the 1.65 that we calculated up above. Now my upper is going to be 100 for that bound. And again, the reason I'm using 0 and 1 here is because these are the z-scores. And the z-scores for my particular case right here is the mean is at 0, right? Z-score. And 1 standard deviation away, okay, and then this is 2 standard deviations away, and the 700 is in between those two values. It's a z-score. So I'm going to use 0 and 1 and paste, and of course if you are using the regular operating system, you don't have the updated, I guess it's StatWizard or something, it's just going to be normal CDF 1.67, 1.65, I'm sorry, and the 100. Okay, and then you hit enter, and then there it is. Okay, the answer that we were looking for, oops, which is right here, the 0.495. And of course, this would round the fourth decimal to 5, right? Okay, and so that makes us happy, okay, that we've done this in a good way. So 4, state the conclusion in the context of the question. All right, and again, they're using probability, so let me write it out. Let's see, 4.95% of SAT math scores will be higher than 700. Okay. And there's how you would write it with the percentage. And that makes us happy because we've done all of this stuff before. All right. Now, you can do the same thing with the lower. Okay. And so here's our example, and we're going to start from scratch. All right. And so the score will be lower than 500. All right. So let's draw our normal curve. I apologize. This looks like garbage, and I can't take it, so I'm going to draw it over. Ugh. You know what? I'm just going to have to deal with it, all right? Here's our 514. Here's our 627 and 740. 627, 740. And of course, now we need to go down, right? Because it's going to be lower than 500. So what is that? So now you have 714 minus the standard deviation is 113. And so now you get 401. And it should be right here at about this point of inflection. 401. And then I'm going to subtract 113 again and get 288. All right. And so the 500 is pretty close to right here. And then it's everything lower. So I'm going down this direction. Okay. Now, remember, this tail is getting closer and closer and closer to the x-axis as I get further and further away. So that shaded area is pretty much going to 0. I can't even get any blue marker in there. So now you show the calculations for the probability, and I have to find the z-score of 500. Okay, and so that's going to be 500 minus 514 divided by 113. And again, we're using parentheses here. Parenthesis, 500 minus 514, close parentheses, divided by 113. And now my z-score is what we found before, a negative 0.124, right? Because I'm trying to use 3 decimal places. Now, I don't have another z-score to calculate because I'm going down this way. But what seems like the most reasonable z-score to put down here where this area is going to be about 0, all right? So as I'm doing my z-scores, and this is 0, and here's negative 1, negative 2. This is going to go out, where is it about 0? Probably negative 100 is another good choice, okay? And if you said that, give yourself a cookie, all right? Pause the video, go to the refrigerator, get the cookie. I'll wait, all right? Now that you're back, so now I'm going to put my normal CDF in, and my left side is 100, right? The leftmost value is over here, that's 100, comma, my rightmost value comes from right here, negative 0.124, and that's going to give me my area under the curve, my probability, all right? So again, we have second, vars, 2, I'm going to go negative 100, I'm going to go negative 0.124, 4. Again, the mu is 0 because I'm using z-scores, and the center is 0, and the standard deviation is 1 for the z-scores. And so I hit enter again, and I get 0.451. And you'll notice, this is just barely below half. So being barely below half means we've probably got about half the curve under here. What does this represent? About half. And so that confirms in our gut what we can see visually, mathematically, and so that makes us really happy here. Now, note. Let me scroll this up just a little bit so that there's room, okay? If you put normal CDF, F, and you got these backwards, you put in the 124 and the minus 100 because you thought it's bigger, because its absolute value is bigger, what will come out will be a negative 0.451, but we know that probabilities are never negative, and so it's probably okay to ignore that negative sign if that happens, all right? So if you flip them around, it just turns out that the probability ends up being negative, and that's okay, as long as that's your only error, all right? And so this is not making us happy, but it's not making us terribly upset. Just be careful, all right? And now last but certainly not least, we do want to state the conclusion of the problem in context. And so this means that 45.1% of SAT math scores will be below. Was it below or less than? I don't guess it matters as long as the grammar is correct. Will be below 500. Okay? And that makes us happy. So this concludes the examples for this instruction. Next, we're going to go on to the inverse norm and how to use it when we need to get a z-score from a percentage. Have a great day, and thank you for watching.